So the quantum mechanical model was developed in the early 20th century and replaced the Bohr model. It really rose out of physics. It was revolutionary because instead of just treating electrons as particles of matter, which they are, it also sees them as as waves. So electrons behave like particles, but they also behave like waves. So in the quantum mechanical model, instead of having an orbit that is just like the Earth's orbit around the sun, a nice predictable path that the Earth flies on, the quantum mechanical model has something called orbitals. And so the fact that these two words, orbits and orbitals, are so similar makes it kind of confusing for students. But they weren't thinking about students when they came up with this. So an orbital is really more of a probability map, a statistical distribution of where the electron is likely to be found. We can't really say that it's definitely going to be in that region, but we're going to say it's probably going to be in there. So it is baseball season. We can compare electrons to baseballs. Baseballs obey what's called Newtonian physics. This is the sort of physics I like because it's relatively easy to understand. You throw a ball and you can predict where it's going to go, right? So a pitcher pitches the baseball, and we can predict based on the direction in which it's thrown and the force with which it's thrown and air resistance and all of those things, the force of gravity, we can predict exactly where it's going to go. And a pitcher, a good pitcher, can pitch the ball to the same place over and over and over again. The thing about electrons, if you shrunk this down onto this subparticulate level where electrons are, these little teeny tiny things, and you had an electron pitcher pitching electrons, you could pitch the electron the same way every time, and it would go somewhere else every time. It's a little more like the minor league, little league pitchers. You know, the ball kind of goes in the general direction of home plate, but there's very few strikes at the beginning of the season. So if we were pitching electrons and we pitched them to the catcher's mitt the same way every time, 20% of them would fall within this small region here, and 40% within this region, and 70% within this region. I realized that when I made the slides widescreen, it torqued the photo. It's one of my pet peeves, aspect ratios on photographs. Those are supposed to be circles, not ovals. 70% chance it's going to be within this area of this oval. But could it hit the guy in the knee? Sure. There's a 30% chance that it's not going to be within this region. It's going to be somewhere else. Do you find that disturbing? Yes. Yeah. You should find that disturbing. How can you throw a particle exactly the same way and have it behave differently? That is disturbing. The genius scientists that discovered this didn't like it either. Nobody completely understands it. It's disturbing. So electrons and photons of light exhibit what we call wave-particle duality. They act like a wave sometimes, they act like a particle sometimes, they act like both sometimes. So, the difference between orbits and orbitals. Orbits are easy to understand, orbitals not so much. An orbit, nice circular path of where an electron's traveling, and we can understand that. An orbital is a probability map showing a region of probability, maybe a 90% Okay, 90% of the time the electron's probably within this region. Very unpredictable. Okay, so this makes me think of my son Andrew. I think I've mentioned Andrew to you before. So there's a very rough sketch of my house. Here's the front door. So if you were trying to pinpoint where Andrew was, I gave my kids different colors because there's 6 of them and it's hard to keep the cups straight. Cut down on the number of cups being used if everybody has their own cup. So Andrew's color was orange because he came at the end, and so there weren't many colors to choose from. So if we take this map of the house and we at some time identify, okay, where's Andrew? There he is, sitting in the chair, watching wild crafts before school. And now it's time for the bus, and oh, he's still there. And now the bus has left, and he's in the bathroom. And then later, he's in the kitchen. And he might be out in the backyard. And he used to, he doesn't anymore, thankfully. He is 7 now. He used to sleep in our bed, or next to the bed. But sometimes he'd sleep in his bed. But you get the idea? When Andrew is officially home, most of the time you'll find him on the property, right? Except for that time when he was 2 and he stole the big wheel across the street and drove it 3 blocks to his uncle's house. That was kind of scary, right? So Andrew is a lot like an electron. He moves around a lot and he's not very predictable. But this region of probability is a lot like the orbital. It's actually a 3-dimensional volume in space where it's very likely that you'll find the electron.